Dividing fractions is going to work just like multiplying fractions, and you'll see what happens on this one. When you divide fractions, what you want to remember is that we actually never divide it. This division gets changed to multiplication, and then we flip the second fraction. It's called multiplying by the reciprocal. So what you're going to want to do is just rewrite the whole problem. Factor it along the way if you can. This first example doesn't have any plus or minus signs, so there's no factoring to do. But you have 6m squared n to the fifth over 5m. Now that division will change to multiplication, and then we're going to flip our second fraction. So this 3m will be on the top over 4m cubed n cubed. Alright, now we can look for anything that we may be able to reduce before we multiply straight across. For me, I tend to just look at the coefficients. So I see the 6 and the 4. You can divide both by 2 and you get a 3 and a 2. Alright, so multiply straight across for these. You have your coefficients 3 times 3, so we get a 9. And then m squared times m. We're going to go ahead and add those exponents, and we get m to the third power. And then your n over 5 times 2 is 10. M times m to the third is m to the fourth. It's a 4. N cubed. Alright, so because we have m's in two places and n's in two places, we can keep going with this example. First look at the 9 over the 10. If you can reduce a 9 over 10, keep going, but 9 over 10 actually stays as a 9 over 10. It doesn't reduce. And then when you are dividing these m's and dividing these n's, you're going to subtract your exponents. So m to the third over m to the fourth, you subtract 3 minus 4 and you get a negative 1. And then your n, 1 minus 3 is negative 2. So for this example, we have two bases with negative exponents. So those are actually going to go to the bottom. The 9 is going to stay on the top. On the bottom you have the 10, and then your m to the positive first power, n to the positive second power. And that will be our final answer for that one. Alright, so this is starting to get filled up and a little sloppy looking. Let me see if I can try to separate a little bit. Alright, so moving on to the next example, you do see we have plus or minus signs, so we're going to be able to factor this. So we will just rewrite the problem in factored form, and we're going to remember to multiply by the reciprocal as we do. So this first fraction will stay exactly the same, but let's go ahead and factor it. Factors of negative 5, it's a trinomial, so factors of negative 5 that add up to 4. We have a positive 5 and a negative 1 over, now the denominator 3x minus 3, we can factor out a 3. So a GCF of 3, and we have x minus 1. Now our division we're going to change to multiplication. And then this x squared minus 25, let's make that a fraction. Let's put it over 1. And then we're going to flip it because we multiply by the reciprocal. So the 1 is going to go up here over x squared minus 25. That's your difference of squares. You're going to have x plus 5 and x minus 5. Alright, so now what can we cancel? How can we reduce this before we see what we have left? You have an x plus 5 on the top with an x plus 5 on the bottom. These x minus 1s are going to cancel. And that's all that I see that will cancel. So in the end, you have a 1 over, you've got this 3, and then the x minus 5. And then we'll go ahead and distribute that 3. So our final answer will be 3x minus 15. Alright, last example. Again, factor everything that you can factor, and we're going to flip and multiply that second fraction. So n squared minus 9, difference of squares, n plus 3, n minus 3, over n squared plus 6x plus, or 6n plus 9, factors of 9 that add up to 6, that will be a 3 and a 3, so n plus 3, n plus 3. This division becomes multiplication, and then we're going to flip those. So that 16n goes on the top, no factoring we can do there. 4, I think that's a typo, that should be an n. 4n squared minus 12n. We can take a GCF of 4n out of that, and we're left with n minus 3. Alright, so we have everything factored. Now we're going to reduce this by canceling anything we see in the numerator that we also see in the denominator. So this n plus 3 is going to cancel with one of these n plus 3's. It can't cancel both of those out. It's just a 1-for-1 deal. So 1n plus 3 will cancel 1n plus 3. I see an n minus 3 and an n minus 3. This 16n and 4n, because that is multiplication between the 16 and the n and the 4 and the n, you can go ahead and cancel those n's, but the 16 over 4 will reduce. If you divide those both by 4, you get a 4 and a 1. So, in the end, what do we have left? In the numerator, it looks like you just have that 4 up there. In the denominator, you have a 1 times the n plus 3, or just n plus 3. And there's our final answer on that one. So just remember to change the division to multiplication and flip your second fraction, and then it will work just like your multiplying rational expressions work.